All right, so today we're going to talk about the law of sines. This week's homework is going to be on Delta Math, so if you have not done so, please make sure to log in using the teacher code that I have here. Now, law of sines is pretty straightforward. Um, Essentially, what it says is for every angle measurement that you have in your triangle, um, the sine of that angle, the ratio between the side of the angle and the corresponding side is equal to the sine of B with its corresponding side and sine, and that's also equal to the sine of C, angle C, as well as the corresponding side. Now, the capitalized A, B, and C, these are my angles measured in degrees. So for a little bit, we're going to take a break from our radian measurements. And we're going to be using degrees once again. A, B, C are the triangle sides. Now, in case you don't remember how these sines and angles work together, let's say I have a triangle, it doesn't really matter, with A, B, C, like so. The corresponding sides are always going to be the one across from the letters. So, for example, I'm going to just color code these. Hopefully, this makes sense. I got A on this side. Side A is over here. If B is the following angle here, side B is here, and side angle C is here, side C is on the other side. Okay, so let's jump into an example. Now, for this lesson, we're not going to look at um, cases where there could be more than one triangle. So I don't want you to worry about that. In fact, you probably won't even think about that. So anyway, don't worry about that. Okay, for our class is just going to be one singular triangle. So let's go ahead and get started. We have one set that we can set up here. And what's nice about this one is this is also another set of ratio that I have. Now, personally, you can see that for what's given to us, it's always going to sine the angle divided by the side, sine the angle divided by the side, sine the angle divided by the side. It is also true that side over your angle is this relationship is obviously true at the same time, right? All I got to do is to take the reciprocal of everything, and this is automatically true. So personally, now it doesn't really matter if you're cross multiplying anyway, but personally, I like to have my variable in the numerator. So I'm going to do x over sine of 20. That should equal to, now this is a side, so 25 over sine of 130. Now, of course, you're going to need your calculator for these. So I have my TI-83 here that I'm going to use. And remember to make sure that you are in degree mode. If you are not, make sure to go to mode. I believe the third one down, and click on degree. Okay. Now, the other thing that you want to make sure you have on, or I'm sorry, I'm sorry. What I'm going to do here is I'm going to just simply, because I just isolate my x, I'm going to multiply both sides by sine of 20. And so x is equal to, I'm going to put all this into my calculator at the same time, 25 divided by sine of 130, close my parentheses, multiply by sine of 20. I get 11.162. Now, this one doesn't have units, although it is a triangle. It might be a good idea just to include units in there, just in case there were, right, if it's meters or something. Now, this second one is a little bit trickier because they gave me angles, 2 out of 3. So I can actually set up this equation first, this relationship, x over sine of 37. So that one works. That's not an issue. There's no side length here, so I can't use this 54. I have 10, but there's no angle. Now, what's good is they gave me 2 out of the 3 angles, right? And I know that a triangle has 180 degrees. So 180 minus 37 minus 54. I believe this is 89. Just to double check. Yes, this is in fact 89 degrees. Okay, so with that, I can now set up my equation where I have 10 over the sine of 89. Okay, again, I'm going to multiply both sides by sine of 37. So this side will cancel out. And so x is just equal to whatever I multiply out here. 10 divided by the sine of 89 multiplied by the sine of 37. Oops, I did not write down 89 here. Okay, hopefully that's not too bad. Let's take a look at the last one here. The last one, I need to solve for an angle. Now you do need to be a little bit careful because I can't just put my angle measurement into the ratio, right? It should be sine of that angle, right? So I want sine of x over, now the corresponding side is 10. And what they give us is sine of 45 over 8. The first thing I'm going to do is, of course, multiply by 10 on both sides in order to begin isolating my x. So here I have sine of x is equal to, now I'm going to just leave this as is for now. You could simplify this to 5/4 if you would like. It's not a huge deal. Okay, so this is going to be some decimal or some number that I have. Sine of 45 times 5 over 4. This is some number. What I can do here is, in case you don't remember, because right now I'm looking for an angle, right? So what I have normally is whatever trig function I have, sine, cosine, tangent, I'm going to use sine. I have sine of some angle is equal to some ratio, or we can think about this as just some number. What I need to do is to set this up so I have inverse sine in order to take the ratio to get back my angle measurement. So what I can do here, you can think about this as a couple different ways. You can just simply rewrite this as x is equal to, because that's my theta, of inverse sine of all this. That's fine. I like to think of it as I'm taking the inverse sine on both sides because I think that's more explicit to me. Like that makes sense to me. All right, so I'm going to take the inverse sine of this whole thing. Now, it might be helpful to just kind of put this in the calculator first. So you're going to get some number here, right? And then take inverse sine of your answer. So your calculator, you can do second negative. The negative has an A and S, meaning the previous answer in your calculator memory. It'll take whatever you had in there, so that way you're not rounding the number multiple times. If you can do the inverse sine of this whole thing, 5 over 4 sine of 45. Now just you gotta be sure to make sure you put in where you need your parentheses. But either way, however you try to do this, for me, I'm going to get 62.114 degrees. Okay, so I really encourage you to try this one for yourself just to make sure you know what you're doing. Okay, so the next few I'm going to go ahead and do for you. I would practice these and then to come back and look at the answers if you would like. But it says find AC, so this is my angle, I'm sorry, my side that I would like. Now, AC really should be that, but that's okay. It doesn't matter. Okay, so x over the sine of 22. That should equal to, again, my side length is 24, but there's no angle given to me. But what's nice is, again, I can do 180 minus these two values. The sum of these two, 118 plus 22, this is going to be 140 degrees, meaning this side must be just 40. So sine of 40. Again, I'm just going to multiply sine of 22 on both sides. And I really got to start giving myself more space on the left. And so I got 24 divided by sine of 40 multiplied by sine of 22. And I get, this time I just want the nearest tenth. This is equal to, now it says 13.9868 dot dot dot. If you round to nearest tenth, that's going to be 14.0. Now, specifically also, this is AC, so I really shouldn't write X. I should say AC is equal to 14.0 units. AB is over here. Again, I want to set up my relationship. I have X over sine of 53. That's going to equal to, now this time that relationship is already visible to us, sine of 44. Again, multiply both sides by sine of 53. So therefore, X, or AB, really, AB is equal to, again, 7 divided by sine of 44 multiplied by sine of 53. That's going to equal 8.04 or 8.0 units. So these aren't too bad, I don't think, overall. They're pretty straightforward. It's really just make sure you know where your information or what your relationships are. BC, this is the side that I want, so I can write X, or if you just want to write BC here, right? I label where I am just to kind of help myself know what I'm looking for. But BC over the sine of 39. Again, I don't know what this value is, but if I add these, this is actually 90. So this is actually a 90-degree angle. Okay, so 27 over sine of 90. For those of you that are like really on top of like our sine cosine tangent of like our quadrantals and stuff like that, you'll know that sine of 90 is actually just 1. If you didn't, that's okay. Either way, I have to multiply by sine of 39. Okay, so I'm going to do sine of, or I should say 27 times sine of 39. If you divide by sine of 90, you'll get the same answer. Even if you don't, you'll still get the same answer because it is 1. Again, 16.991 dot dot dot. This rounds to 617.0. So I got X over the sine of 63 is equal to 9. Again, I don't have the value of this angle. Once again, 63 and 101 is going to be plenty of information for me to solve that last side. So 100 minus 63 minus 101, I have 16 degrees on this side. So sine of 16. Once again, multiply it by the sine of 63. Sine of 63, that will cancel. 9 divided by sine of 16 times sine of 63. I get X is equal to 29.1 units. I don't know why I boxed that one when I didn't box the others. I'm just going to do a couple more, and I think I'll wrap this video up, try to keep it short. In the diagram, which angle measure can be found using the given measure by applying the law of sines? Okay, so we can see that this is an angle or relationship that we can set up. Since I have KL, J, angle J is the angle that we would look for. So we want to find this measurement. What I have is sine of J over 36 should equal to sine of 110 over 70. So I'm going to multiply both sides by 36. And then what I'm going to do here is sine of J, I'm going to take the inverse sine of both sides. So that means J, or specifically the measure of angle J, I have inverse sine of sine of 110 divided by 70 multiply by 36. Nearest whole degree, I have 29 degrees. Last question, because it is on the delta math, and I just want to make sure you know what the heck it's talking about. It tells us in the triangle LMNN, you have a side that's 92 inches, measure of angle N, measure of angle L. We want to find length L. Sketch out LMN. So any triangle is fine, doesn't really matter. I got L, M, N. Remember that the side with the same name, but that's lowercase, is the one across. So N is here at 92 inches. I need to find L. Measure of N, this is 46. Measure of L is 11. I can set up my equation. L over sine of 11 is equal to 92 over sine of 46. So this one, again, it's the exact same problem as the previous ones, but you just got to make sure you draw your picture to really know what the heck it's asking you for. So what I got is L is equal to 24 nearest inch. So that's it, 24 inches. Hey, I hope this helped. Let me know if you need any help. Thank you very much.